Acids and bases are a special type, or two special types of solutions that we need to consider. I have a chart here to compare the two to each other. The first thing that we will use to compare an acid to a base is the pH level. A low pH, less than 7 on the pH scale, will mean that we have an acid. A high pH, greater than 7, means that we have a base. Now, another thing we can do is to monitor the taste and the feel of the chemical. Now, keep in mind, it's not safe to test the taste and the texture of all chemicals. So, take my word for it that acids are sour. If you look down here like vinegar or orange juice, lemon juice, you will know that they do have a sour taste. Bases are bitter. They taste bitter. If you've ever accidentally had some soap in your mouth, you know that it has that bitter taste. Bases are also slippery. Acids don't feel any different to us than other liquids, but we know if we feel something that feels slippery that we are dealing with a base. Now, you see here we have blue litmus red and red litmus blue. There's a type of indicator called litmus paper that comes in two different colors, either red, which actually looks more like pink, and blue. Now, if I take a red piece of litmus paper and put it into an acid, it's not going to change color. So I don't know if I have an acid or not. That's the reason I use blue litmus to test the acid. The blue litmus paper, if it comes into contact with an acid, will turn red. And that is a positive result for an acid. Now, for the base, I need to have the red litmus paper to touch the solution in order to see whether or not it turns blue. Now, an acid will produce a hydrogen ion in water, and a base will produce a hydroxide ion in water. And I have some examples here of acids that you might find around your house, like vinegar, aspirin, eyewash, and then some bases, Drano, bleach, and Tums. Now, when I was talking earlier about pH, we said that an acid was less than 7 and a base is greater than 7. And we talked about using litmus paper to test for the acid or the base. Well, if I had a solution and I tested it with the red litmus paper and the blue litmus paper, and neither one of those indicator papers turned colors, then I would know that I did not have an acid or base. I would have instead a neutral solution. And so this equation I have set up here is the process of neutralization. When we add an acid to a base in the right proportions, we will get a salt and water. Now, the reason that happens is because that hydrogen ion in the acid will react with the hydroxide ion in the base to form the water. And the stuff that's left over will form the salt. Now, salt and water are both what we call neutral. They have a pH of 7. So we have a low pH added to a high pH to meet in the middle at neutral. So if you look at my example, we have hydrochloric acid added to magnesium hydroxide. This is the acid, this is the base. And when they combine, the magnesium and the chloride, the leftovers, will form the salt. The hydrogen and the hydroxide will form the water. We'll practice some neutralization reactions in class.